Now, after we have created a database, we need to know how to select a database from our existing list of databases. So we have the use database statement for this. All we have to do is give the keyword use and then state the name of the database. Now this database which you selected remains default until the end of a session or execution of another use statement with some other database. So if I put my mouse pointer over here, so we see that currently we are using the Sparta database. So now I want to use the happy database instead of the Sparta database. So I will write the command for that, use, and then after that I need to give in the database, which would be happy. I'll press semicolon, I'll hit execute. So again, commands have been completed successfully. So now we see that the database has changed from Sparta to happy. So currently we are inside the happy database. Now we'll see how to delete a database, or in other words, how to drop a database. So we have to give in the keywords drop database and then specify the name of the database which you want to drop. So now I want to drop this Igneous database. So let me write the command for that. Drop database and then the name of the database is Igneous. So I'll press semicolon over here. I'll hit execute. So again, commands have been completed successfully. Now I'll hit refresh. So we have only two databases, Happy and Sparta. So the database Igneous has been dropped. So this is how we can create, use and drop a database. Data types in SQL. So a data type basically defines the kind of data that will go into a particular column. Now it needs to be kept in mind that all the entries of one particular column would have the same data type. So let's take this eSalary column for example. We see that the first entry is of integer type. The second entry is also of integer type. Similarly, all the entries of this eSalary column are of integer type. Now let's take this department column. Here we see that all the entries of this particular column are of character type. Now that we've understood what exactly are data types, let's have a look at the different data types available in SQL. Let's start with the numerical data types. So we have the big int data type, which helps us to store really big values. So you can see the range of big int over here. Then we have the int data type, which helps us to store reasonably big values. After that, we have the small int data type, and the range of small int is from minus 32,768 to 32,767. Then there's tiny int, and the range is only between 0 to 255. After that, we have the decimal data type, and it is used to store fractional values. So the decimal data type takes in two arguments. First is the size of the value, that is the total number of digits. Then we need to specify the number of digits after the decimal point. Let's say we want to store the decimal value 12.50. Here the size would be 4 because the total number of digits are 4, and value of d would be 2 because there are 2 digits after the decimal point. Now let's have a look at the character data types. So first we have the char data type. This takes in one argument, which is the size of the value. Let's say you set the size to be 20. This would mean you cannot give in a value which would have more than 20 characters. Now you need to keep in mind that char is a fixed length data type. That is, if you set the size to be 30, but you're given only 3 characters, then the memory which would be consumed is of 30 characters. So you're basically wasting the memory over here. Then we have the varchar data type. This again takes in size as the argument. Now varchar is a variable length data type unlike char. So here if you set the size to be 30 and given only 3 characters, the memory consumed would be only 3. Then we have the text data type. So this data type can take in a string with a maximum length of 65,535 characters. Then we have the date and time data types. Well, start with the date data type. So this data type helps us to specify the date in this format over here. Let's say we want to store the date 2nd January 2019. Then first we will give in the year, which would be 2019. Then we'll specify the month, which would be 01. And finally we'll specify the day, which is 02. After that we have the time data type, and this helps us to specify the time represented in the format over here. Now let's say I want to store the time 8:30 AM 23 seconds. So first I'll specify the hour, which would be 08. Then I'll specify the minutes, which is 30. And finally specify the seconds, which would be 2, 3. Then we have the year data type, which just holds the year values such as 1995 or 2011. So constraints are basically used to specify some rules on the data and limit the type of data that can go into a table. And in this session, we will look at these 4 constraints: not null, default, unique, and primary key. Let's start with the not null constraint. So by default, a column can hold null values. And with the help of the not null constraint, we can ensure that a column does not have null values. So the not null constraint basically ensures that a field always contains a value. For example, if we assign the not null constraint to this eSalary column over here, then every single entry of this column should have a value. Then we have the default constraint. So the default constraint is used to provide a default value for a column. So the default value will be added to all the new records if no other value is specified. For example, if we assign the default constraint to the EH column and set a default value of 25, then all the entries of this column will have the default value of 25 if no other value is specified during insertion. Then we have the unique constraint, which ensures that all the values in a column are different. For example, if we assign the unique constraint to this ename column, then every entry of this column should have a unique value. And finally, we have the primary key constraint. So the primary key constraint uniquely identifies each record in a table. Or simply put, it is just a combination of the not null constraint and the unique constraint. So when we assign the primary key constraint to a column, then that column shouldn't have any null values and all the entries should also be unique. For example, if we assign the primary key constraint to the employee ID column, then there should be no null values in this column and all the entries should also be unique. So these were some of the constraints in SQL.
Let me just start off with my first topic, which is why ACID properties. Alright guys, now when I talk about ACID properties, or when I'm trying to explain you why did ACID properties came into picture, so in order to know that, you guys should know the first and foremost important topic, that is transaction. So well, a transaction is nothing but a logical group of tasks, or you can define it as a group of commands that basically change our data which is stored in a database. A transaction is always a single unit, that is, once you're doing a certain transaction, it is done once and it's like a cycle which has a lifetime. So you have to execute one transaction, or you can do one work at a time. In a very simple word, I can say that if you're doing a certain transaction, then you can do one work at a time. Now let me move on and give you a small example related to transaction so that you guys will get a clear picture of what it is. So let me just minimize this part and open my SQL Server Studio. Let me just exit this code. Alright, so when I begin my transaction, what I'm going to do here is I'll be writing begin transaction. Now under this, I'm going to make use of my SQL query statements, that is update. So update.
Just a quick info guys. Intellipaat provides online SQL training in partnership with Microsoft. The course link of which is given in the description below. Now let's continue with the session.
Employee, which is my employee table. Alright. Set the employee age, that is the abbreviation I'm making use of, which is E_H, is equals to, let's say it should be 50, where employee name is equals to Sam. Alright, now let me just select these two statements, what I have written here, and execute it. So as you can see, it shows one row has been affected. Now in order to fetch my results, I'm going to simply make use of the SQL statement, that is select star from employee and execute this. So now guys, as you can see, our previous age was, or the previous employee age for the name Sam was 45, and now it has been updated to 50. Now a transaction is not complete without the two operations that are rollback and commit. Now let's say I want to roll back this operation, that is whatever employee age which has been modified or the new employee age, I want the previous employee age back. So what I got to do is I'll just go back and simply type here rollback transaction. Alright, let me just give this space over here and select this. So it shows commands completed successfully. Now I'll move on and select this part and execute it again. So as you can see guys, our previous employee age has been rolled back. So rollback is one of the SQL statements which basically rolls back your entire operation. Now the main reason why I'm explaining you these two parts, I'll tell you the reason later. Let me just show you how do you commit a certain transaction. Now let's say I want to remove this rollback transaction statement. So I'll just delete this part and I'll again select these two statements, execute it, and it shows one row has been affected. Now I'm just gonna select my select star from employee statement and now I'll execute it. So now my employee age has been modified to 50. Now let's say I want to commit this particular transaction. So my commit statement will commit the whole changes or the modification what I have done in the DB forever. So I'm going to write or make use of commit transaction. All right, let me just give space over here and select this part and execute it. All right, so it shows the message commands completed successfully. Now I'm going to simply select this statement, that is select star from employee, and execute this part. All right, so now our transaction has been committed. I just gave you a hands-on session of transaction where I was beginning a transaction and I had taken into account of an employee table where my first process was I was basically updating the employee age from a certain number to a different number, after which I tried making use of the SQL statement, that is rollback. So using that particular statement, I was able to get back the previous age of the employee which was existing in the employee table, and then I'd made use of the commit transaction, due to which the modification or the changes what I had done in the database will always get committed or will always be saved forever. Like even if the system crashes, it will be there existing on our DB. Now let me just move forward and talk about the various aspects why did asset properties came into picture. Now let me take a use case where we have two people. So one guy's name is Amit and the other guy's name is Nikhil. Amit's bank account has 3,000 rupees and Nikhil's bank account presently has 0 rupees. So what I'm trying to do is I'm trying to transfer this 3,000 rupees from Amit's bank account to Nikhil's bank account. So when the transaction P comes into picture, so I have divided it into two parts, that is P1 for Amit and P2 for Nikhil. Now I've written a small pseudocode over here which talks about that I'm opening Amit's account and initially Amit's balance is equals to the new balance. Now when my deduction of money will take place, then that 3,000 rupees will get deducted and then my remaining balance or my new balance will be equals to the remaining balance, that will be equal to 0. Moving forward to Nikhil's bank account, I have written the same algorithm, but here 0 will be added with the new money that has been credited to his account, that is 3,000 rupees. And his new balance will again be equal to the remaining balance. So now his remaining balance is 3,000 rupees. So guys, this basically forms a part of one transaction. And if this whole operation is successful, then only we can commit the database. Otherwise, there can be such cases where 3,000 rupees has been deducted from Amit's bank account, but that rupees or that amount of money never reached Nikhil's account. So in such cases, it is basically called as a fraudulent transaction, and such operations are not considered as legitimate when we talk about transactions or when we talk about the reason behind the existence of asset properties, because that transaction or that DB has to go through those principles. And if your operation is failing, then you have to make use of the rollback statement so that you again start the transaction from the beginning. That's the reason why there are certain guidelines and these properties the DB has to adhere to, and that's the reason why asset properties came into picture. Now let me just move on and talk about what are asset properties. Well, let me just start off by giving you the brief abbreviation of asset properties. So asset properties basically or essentially stands for atomicity, consistency, isolation, and durability. As you can already see, it is given in the slide. Well, Asset properties are again one of the most important aspects of database, and I have already given you the abbreviation. So let me just move on and talk about what is atomicity. So atomicity generally means all or nothing. Well, again, whatever is written in my slide, it basically says that it does not follow any middle approach. That is, there should be no partial occurrence of transaction happening. I'm going to be showing you an example of what I mean by the partial occurrence of transaction. So, well, what I mean by this particular statement, that is my first statement, which talks about atomicity generally means all or nothing, is if a transaction is taking place, I'll go back to my previous slides where I had explained transaction. So let me just brush in that part up again. So if a transaction is taking place, it has to take place full. Otherwise, it will again start from scratch. That is, the rollback operation will be happening and then it will get committed. If that part doesn't happen, then our database will be considered as inconsistent or incompetent, or it will also be called as not a good DB. So let me move ahead and give you the example of those two bank accounts again. So what we did was I have written the same pseudocode. Now what's happening is, again, I have taken into picture of Amit's bank account, and the pseudocode is talking about deducting 3000 rupees from Amit's account initially, and then that 3000 rupees is then added to Nikhil's account. Now this whole part, or this whole one operation, is called as a transaction. So if the operation is success, then you will be able to execute it, or you can commit the database. But what if, again, I'll be repeating the same set of statements, that if the operation fails in the middle, that is, let's say that the money has been deducted, that is 3000 rupees is deducted, but that 3000 rupees is not added to Nikhil's account. So when this operation is failing, then our operation has to again start from scratch. That is, it will roll back and it will start from scratch, where we'll deduct the money from Amit's account and then that money will be added to Nikhil's account. And this is essentially what atomicity means, which is either it is all or it is nothing. Now moving on to our next topic, which is consistency. Well, consistency is nothing but it ensures that whenever a transaction has ended, so let's say we had deducted money from Amit's account initially and that money was added to Nikhil's account. So let me just go back to my previous slide. I will explain you consistency from here itself. So, well, when we deducted money from Amit's account and then it got added to Nikhil's account, so what happens is the state before the transaction, that is, before Amit's account had 3000 rupees and Nikhil's account has 0 rupees, and state of the DB after the transaction has taken place has to be the same, which also means that at the end of every transaction, all the data which is left must be in a consistent state. So it has to be 3000 rupees before and 3000 rupees after, and that's how you check the consistency of the DB. Or in simple words, I can also say it states that any changes which are happening with respect to the values in an instance are consistent, then it should be consistent with the values in other instance too. Now I'll move on and talk about my next property, which is isolation. Well, isolation generally occurs when there are concurrent transactions, means there are multiple transactions which are taking place. It also states that we can convert a parallel schedule into a serial schedule conceptually and not in real time. Now, of course, you guys must be having a problem in understanding what does this whole statement mean and how do I do that, or how do I achieve it. In order to understand this, so let me assume a table. So I have written a table over here. Now in this above given table, we have concurrent transactions which are running in parallel. So what's happening is when these transactions are taking place, so let's say we have T1, T2 and T3, and in T1 we have a read statement that is reading A, in T2 we have a read statement that is reading B, and in T3 we have a read statement that is reading C. And all these transactions are running parallelly, or I can say are running concurrently. So the CPU, what it will do is it will keep switching, starting from executing our first transaction, then it will execute T2, then it will go to T3, again it will come back to T1. So when I say parallel scheduling, what I mean is, so let's say we have T1, okay, so sometimes T1 runs and then T2 runs again it comes back to T1 and vice versa. So none of the transaction is taking place properly, that is, or I can say according to isolation, one process is taking place or one transaction is happening, then subsequently it again switches to the second transaction and it is not getting completed properly. What I'm going to do is that we have to convert this to serial scheduling, which essentially means let the first transaction complete and then the CPU will switch to the second transaction, or let the second transaction complete, then the CPU will switch to the first transaction, or let the first transaction complete, then the CPU will switch to the third transaction, or let the third transaction complete, then the CPU will switch to the second transaction, which I have shown here. That is, once T1 gets completed, then it goes to T2, or once T2 gets completed, then it goes to T1. Now I think this guy is pretty happy after this, that is, he understood. Now I'll tell you the reason why we are doing serial scheduling, guys. Well, we are doing serial scheduling because we want to achieve or maintain or attain the consistency in database. So I've already explained you what consistency means, that is the previous property, and we are trying to achieve that through isolation. Now I'll move on and talk about the last property, which is durability. So durability is nothing but it basically talks about all the modifications and updates which I'm going to do or which I have done to my database. Let's say I have made use of a lot of SQL query or statements like update, alter, and things like that, or statements like that. Then if I am writing commit that transaction or commit that DB, then what's happening is that database will get committed for the lifetime. So that even when there's a power failure or your whole PC crashes, but when you format it or when you open your MySQL or the SQL Server Management Studio and when you have that database existing, then you will find that database will be there and the changes what you had done prior to that or previous to that will be existing. Now I'll move on and talk about the different keys which are existing in relational database. Now guys, this is very important from the normalization point of view, because when I get into that whole concept of normalization, you need to understand where I'm making use of the candidate key or where I'm making use of the super key, etc. So let me just start off by talking about what are candidate keys. Well, candidate keys are basically the minimum set of attributes which can uniquely identify all the records in a table. Now, the value of candidate key will always be not null plus unique. You can think of candidate key as a primary key also. But in a relation or in a table, there can be more than one candidate key. Now, a candidate key can either be a simple one or there can be a composite key, that is, we have two keys which act as a candidate key. Now, I'll move on and talk about the next key, which is super key. So, the set of attributes which can uniquely identify a tuple or a record is known as a super key. So when you add 0 or more attributes to the candidate key, it then becomes a super key, and a candidate key is a super key, but a super key can never be a candidate key.
Just a quick info, guys. Intellipad provides online SQL training in partnership with Microsoft. The course link of which is given in the description below. Now, let's continue with the session.
Now I'll move on and talk about what is a primary key. Well, a primary key is basically a set of attributes which can uniquely identify a table. Now, primary key essentially adheres to two conditions. That is, when you have a table, let's say we have an employee table and it has different columns like employee ID, employee name, and employee age. So our employee ID will always be unique, and that's how it becomes the primary key of that table. And the other part is it should never be null. So you cannot enter a null value into employee ID. If you do that, you will be violating the rules of employee ID of becoming a primary key. Now, the second point merely states that there can be more than one candidate key in a relation, out of which one can be chosen as a primary key. Now, let me talk about my next key, which is a simple key, that is alternate key. So any candidate key which is other than the primary key is called as an alternate key. Now let me talk about my next key, which also happens to be one of the most important keys apart from primary key. So that is known as a foreign key. So guys, for a very simple definition of a foreign key is what I can think of is, so let's say we have two tables, which is we have a department table and we have an employee table. So as you guys know that in department table, we'll be having several columns which will be consisting of a department ID, a department name, etc. Now in the employee table, we will again be having a department ID because that's how you can uniquely identify that employee, that okay, this employee works for this department. So let's say we have two departments which are IT and finance. Now that will be acting as a primary key in the department table. Now when we move ahead to the employee table, again this department ID will be acting as a foreign key. So a simple definition of foreign key, what I can think of is a foreign key is basically takes into account attributes of the primary key of your parent table, and that basically acts as the foreign key of the child table. That is, if you have an attribute which can only take the values which are present as values of some other attribute, it will basically be the foreign key to the attribute to which it refers. Now the referenced attribute over here of referencing attribute should be primary key. So this is the referenced attribute, and then it is referencing to the DID primary key of the department table. So let me just move ahead and talk about normalization. So the general definition of normalization says that it is a technique of organizing your databases into multiple related tables so that you have to minimize data redundancy. Now when I talk about data redundancy, guys, this term will always strike a chord with you because data redundancy generally means that you are repeating the same data into table multiple times. When I was showing you the hands-on, so let's say I have a database or a department table, and then I have an employee table. So what I'm going to do is, in my department table, I have the DID, I have the department name, I have other sorts of columns which are related to the department. And in my employee table, I have the employee ID, and then I have the employee name as Amit, and then I have the employee designation as, or the employee, let's say the department names. There are two names of department. So if there is IT department and finance department, and that D name also gets carried in my employee table. So that IT, finance, and that is getting repeated. So you repeat IT, finance probably 3-4 times. So that can lead to data redundancy. Also, if I can think of a simple example, so let me take a student table. So under the student table, I have HOD, I have branch, and the office telephone number. And the student ID is our primary key, and the student names are different names. So let's say all of their branches are computer science engineering and their HODs are same, that is Mr. A. So what happens is this Mr. A and computer science is a part of data redundancy, that is the repetition of data is taking place. Now why is data redundancy is such a big evil for a DB? Well, the reason is because it eats up unnecessarily extra space into the database, which leads to different anomalies called as insertion, updation, and deletion. Now getting back to our topic of normalization, well, normalization consists of 4 major parts, which are first normal form, second normal form, third normal form, and then the BCNF, that is Boyce Codd normal form, also known as the 3.5 or higher normal form. Well, if a database adheres to the first normal form, it need not go to the second normal form, or if it does not adhere to the first normal form, then it follows the higher normal form, that is second normal form approaches. Even if it is not adhering to the second normal form, then it follows the third normal form approach. And if it does not follow third normal form, then it has to go through the BCNF form. Now, so these are the 4 major normal forms which are into existence or into picture. But the problem is, if the database, let's say, doesn't adhere to all these normal forms, then it has to again go through a 4th normal form, then a 5th normal form, and the highest normal form, that is a 6th normal form. Generally, if a database adheres to these 4 normal forms, then it is called as a good DB. Now moving on and diving deep to what are these normal forms. So in order to explain that, what I've done is I have taken an example. So through this example, guys, this one single example, I'm going to be explaining you all the 4 normal forms. So in this example, I have taken a salutation as Miss, Mr. and Mr. And in the full name, I have written Sylvia Plath and John Hopkins and John Hopkins. So the address of Sylvia Plath is 1st Street, house number 3. But the address of John Hopkins is basically a composite attribute, as because I had explained to you when I was explaining you composite keys. So it basically acts as a composite key of address where I'm just stating the 3rd street, that is a street name, and the name of the house. Similarly, in John Hopkins, again, I'm stating the 7th Avenue. Now these people have the movies rented, which are Mission Impossible, Die Another Day, and the categories of it. Now when I talk about my first normal form, well, our first normal form states that it should follow the rule of atomicity, that is, each table cell should have a single value, or you can say it should be atomic. So basically all your records must be unique. So what I'm doing here is I have my salutation, that is my full name Sylvia Plath. So Sylvia Plath, so previously if you look at the previous table, so what happened was this Mission Impossible, Rogue Nation and Die Another Day were in the same row, but now when the table is in the first normal form, so these two get split into two different rows. So our name is again being repeated. Similarly for John Hopkins, again Interstellar and Gravity is being which was there in a single row is now being divided into two different rows. But again guys, this table has some problem. That is, since I had already explained you that it consists of a composite attribute or composite keys, and then there's the full name John Hopkins. So now this table is again not fully correct, though it is adhering to the first normal form. What if we want to see the full address of the full name John Hopkins, or we want to see a single column primary key? So when I talk about that part, I'll have to move on to my higher normal form, that is the second normal form. So my second normal form basically or essentially states that my database firstly should be in the first normal form and should and necessarily consist of a single column primary key. So now what I am doing is, again I have the same name, that is John Hopkins, and I have the composite key attributes, but then here I have pretty much created a new table under which I am adding a new ID, which is the primary key of table 1, and this primary key of table 1 is now the foreign key of our table 2. Now I'll explain you how this is acting as a primary key of table 1 and how it is acting as a foreign key of our table 2. So let me just talk about the names, that is Sylvia Plath has been given an ID of 1. Again, John Hopkins, who resides in the 3rd Street 45th address, has been given an ID 2, and John Hopkins, who resides in the 7th Avenue, has been given an ID 3. So now when I am trying to differentiate our addresses based on our full name, I will be able to do that. That is, leave that part aside. Now let's say I'm taking movies rented. So now our Sylvia Plath, who has been given an ID 1, has rented the movie Mission Impossible, Rogue Nation. Again, Sylvia Plath, who has been given an ID 1, has rented another movie, which is Die Another Day. Now John Hopkins, who has been given an ID 2 and who happens to reside under the address 3rd Street 45, which is also the composite key, has rented a movie Interstellar. And again, John Hopkins with the ID 2, who's living in the address 3rd Street 45, that is the composite key, has rented Gravity. Now the third ID that has been assigned to the John Hopkins name again, but this time he's the person who lives in the 7th Avenue. So this is where the second normal form comes into picture, guys. So I have pretty much clubbed in a new column, that is ID, which acts as the primary key of our table 1. And this ID is then referencing to in our table 2 as the foreign key, because this basically refers to the parent primary key of or the primary key of our parent table. And this is how we were able to solve the address issue, that is the composite attribute issue, by simply providing unique values, or that's what our second normal form addresses on. That is, it should consist of a single column primary key, and that is what happening in our table 1, and this primary key acts as a foreign key in our table 2. Now guys, before moving on to third normal form, so what if I remove the full name, that is John Hopkins? Alright, so what if I remove John Hopkins, this name, by let's say Alice Hopkins? So if I remove Alice Hopkins, then I'll have to change the salutation also, because Alice Hopkins will now be a Mrs. and not a Mr. Of course, the gender thing comes into picture over here, guys. So if I take into account of Alice Hopkins, so what my point is, what I'm trying to explain is, I'm basically trying to explain you a transitive functional dependency. So let me explain you what a transitive functional dependency means. So as I had already told you, if we remove John Hopkins and add pretty much Alice Hopkins over here, then I'll have to change the salutation also. So what it means is, if you try to change a single non-prime attribute or a single non-key attribute, and if the other non-key attribute gets changed because your salutation is dependent on full name, then that part is called as a transitive functional dependency. So if we move on to a third normal form, I'll explain you why. Our third normal form basically talks about that the database should be in second normal form and it must not have any transitive functional dependencies. So when I move on to my previous table, so in this table, which is already in second normal form, guys, our salutation is dependent on full name. That is, your non-prime attribute should not be dependent on any other non-prime attribute other than the prime attribute. So here our prime attribute or the primary key is the ID, but here there's a big loophole that our salutation is dependent on the non-key attribute, which is full name. Now, how do I solve this anomaly, or how do I solve this ambiguity? So in order to solve this ambiguity, I had divided it into three tables. So as you can see, guys, in my first table, I have ID, which is the primary key, I have full name, I have the address, and then I have the salutation ID. And my second table, so again, our table 1 and table 2 is from the previous normal form, that is, it is in the second normal form, so it's pretty much the same thing. Now, the third table, what I have divided is, here I have divided the salutation, so I have taken the salutation into a different table, and I have clubbed in a new column, that is salutation ID. So now if I remove John Hopkins with Alice Hopkins, or John Hopkins with, Howard Hopkins, then I'll be able to write the salutation that will be either doctor or miss, and I'll also be able to provide it with a unique key or the salutation, a unique salutation ID that is 4 and then can move up to 5 or 6 or 7. So this is what third normal form states, guys, that your database should be in 2NF. So that is exactly our first and second table are in the second normal form, which I had shown in my previous example. And then if there are any transitive functional dependencies, that if one of the non-key or the non-prime attribute is dependent on the other non-prime attribute, then that should not happen. And if such a case is happening, you take that whole column out and make a new table out of it, so that it is also dependent on the primary key. So this is pretty much it about our third normal form. Moving on to our last normal form, which is BCNF. So well, BCNF is also known as Boyce Codd normal form or 3.5 normal form. Here you basically divide your tables further so that there would be only one candidate key present. Let me show you that by a small thing. So what if A is dependent on B here? So A should be a super key.
Just a quick info, guys. IntelliPad provides online SQL training in partnership with Microsoft, the course link of which is given in the description below.
Okay guys, we've come to the end of this session. I hope this session was helpful and informative for you. If you have any queries, leave a comment down below.
Thanks